Okay, so we keep hearing about bigger and bigger AI models, right? But what if bigger isn't always better, you know?
Yeah, that's the question that this paper is tackling memory layers at scale. And instead of just scaling up those dense layers,
The same old dense layers, right?
yeah, they're proposing something pretty different.
Radically different.
Radically different. So these memory layers.
Memory layers.
Yeah.
So not just cramming more data in, but like changing how it's stored and used. Almost like giving it a library just for facts.
Yeah, exactly. They act like knowledge banks within the AI specifically designed for that factual recall, and the results are pretty impressive.
Yeah.
They actually found that adding these memory layers can double the accuracy on factual tasks.
Double. Wow. That's huge, especially for like question answering, knowledge retrieval and things like that. What kind of actual tasks did they actually test these memory layers on?
Yeah, so they used a couple of different benchmarks, well-established benchmarks, natural questions, trivia QA, and hot pot QA. And these cover, a range of those factual tasks from, simple question answering to, more complex reasoning over multiple pieces of information.
Okay. And these memory layers outperformed the traditional models on these benchmarks.
Yeah, consistently.
Even when those traditional models were much larger.
Yeah, and that's what makes this research so compelling, right? They were able to achieve those better results with fewer parameters, which suggests that it's a more efficient way to scale AI for those factual tasks.
Okay, now this is where it gets really interesting for me. They even outperformed those mixture of experts models.
Yeah, those are pretty hot right now.
Can you remind the listener what those are and why it's so significant that the memory layers beat them?
Sure. So a mixture of experts models, it's kind of a way to divide and conquer complex tasks within the AI. Sure. You have these different experts that are specialized in different subtasks, and the model learns to route the right input to the right expert. It's a way to kind of improve efficiency and accuracy.
Okay. Yeah.
So the fact that memory layers outperform these specialized experts kind of suggests that there's something really powerful about having a dedicated system for storing and retrieving that factual knowledge.
Precisely, it seems that for those tasks that rely heavily on factual recall, memory layers just provide a more direct and efficient solution, even compared to those highly specialized models.
Okay, so help me understand how these memory layers actually work. What's going on under the hood that allows them to be so good at handling these facts?
Yeah, so the core mechanism is something called key-value lookup. You can think of it like a dictionary where you have keys that represent concepts or entities and values that represent the associated information.
So if the key is Albert Einstein, the value might be his birth date major theory's famous quotes.
Exactly. And the AI learns to associate those keys and values through training. What makes memory layers unique is that the keys and values are themselves trainable parameters. Wait, so the AI is not just learning the facts, but it's actually learning how to organize those facts in its memory.
That's right. It's learning to optimize that entire key value mapping system for efficient retrieval, and that seems to be a key factor in its success.
So instead of being like a passive storage unit, the memory layer is actively involved in the learning and the organizing of knowledge.
Yeah.
That's pretty cool.
It challenges that traditional view of memory as a static component.
Right.
Here, memory is dynamic and adaptive, playing a crucial role in that learning process itself.
This is fascinating stuff. And they scaled these memory layers up to some pretty incredible sizes, right? How did they manage to handle that much data without everything just grinding to a halt?
Yeah, so that's where the at-scale part of the paper comes in.
Right.
They had to develop some clever techniques to make these memory layers work efficiently with billions of parameters. One technique they used is called product key lookup.
Product key lookup.
Yeah.
Okay, I'm all ears. What is that and why is it important?
You can imagine, searching for a specific book in a library with millions of titles. Product key lookup is like having this super efficient indexing system that helps you pinpoint the exact book you need almost instantly.
Oh, so it speeds up the search process within the memory layer so it can handle these massive knowledge bases. What other tricks did they use to scale these things up?
Another important innovation is how they parallelize the memory across multiple GPUs. So instead of having everything running on a single processor, they distributed that workload, which allowed for much faster processing of those huge memory banks.
This is like having a team of librarians working together to search the library?
Yeah, simultaneously.
Simultaneously, right. They also mentioned something called shared memory. What's that all about?
Yeah, so shared memory is another way to boost efficiency. Instead of having separate memory banks for different tasks or layers within the AI, they used a single shared pool of those memory parameters. And this allows for greater flexibility and reduces redundancy.
So it's like having a multi-purpose room in the library that can be used for, different activities as needed instead of having, separate rooms for reading and studying and research.
Yeah, that's a good analogy. So by sharing those memory resources, they can maximize capacity and streamline that learning process. It's a really elegant solution.
So it seems like they've really thought through the challenges of scaling these memory layers. But I'm guessing it's not all smooth sailing, right? What are some of the limitations that they discussed?
Yeah, one key challenge that they highlighted is memory bandwidth. So memory bandwidth refers to how quickly data can be transferred in and out of memory.
So it's like having a brilliant chef with all the ingredients, but a tiny kitchen.
Exactly. The speed at which that data can be accessed limits the overall performance, even with all of these clever techniques. They're still working on optimizing that memory access, especially for that large-scale production use.
So the potential's there, but there's still some bottlenecks to overcome. Are there any other limitations that they mentioned?
Yeah, another point that they raised is that while memory layers excel at those factual tasks, they might not be the best solution for every type of AI problem. They might not be as effective for tasks requiring more complex reasoning, abstract thinking, or creative problem solving.
So it's a powerful tool, but it's not a magic toilet. It's important to understand its strengths and its limitations. What are some of the next steps for the researchers working on memory layers? What are the big unanswered questions?
One exciting direction is exploring how memory layers can be integrated with other AI techniques.
Okay.
So, for example, combining memory layers with those mixture of experts models we talked about
That's interesting.
could lead to some really interesting hybrid systems.
Yeah, combining the factual precision of memory layers with the specialized skills of the different experts. What other possibilities does that open up?
Another area of exploration is how to make memory layers more adaptable and dynamic. Right now, they're very good at storing and retrieving those static facts. But what if they could also handle information that changes over time or even learn new facts on the fly?
That would be a game changer. Imagine an AI that could constantly update its knowledge base based on new information. It'd be like having a living encyclopedia that's always learning and evolving.
Exactly. And that's just one of the many exciting possibilities that memory layers open up for the future of AI. We've been exploring this idea of memory layers, dedicated knowledge banks that are kind of changing the game when it comes to these factual tasks.
It's like giving AI a superpower for remembering facts. But how do these memory layers actually learn? We talked about that key value lookup, but how does the AI actually figure out which keys and values to store in the first place?
That's a great question. The learning process is actually very similar to how traditional neural networks learn. It all comes down to training on these massive data sets. Imagine feeding the AI just tons and tons of text and code. And during this process, the memory layers start to identify patterns and relationships between words, concepts, entities.
Right.
And
So as the AI reads more and more, it starts to form those connections between different pieces of information, and those connections actually become the basis for the key value pairs in the memory layers.
Precisely. And the beauty of this is that the AI is not just passively storing facts, it's actually actively learning how to organize and structure that information in a way that makes it really easy to retrieve later on.
It's like a student who not only memorizes the facts, but also develops their own system for organizing and connecting those facts, which helps them understand and apply that knowledge more effectively.
That's a great analogy, and this ability to learn and adapt is what makes memory layers so powerful. They're not just static databases, they're dynamic systems that can evolve and improve over time.
So it's not just about cramming in more data, it's about developing a more intelligent way to store and access information. But, we touched on some of the limitations earlier. One that stuck with me is this idea of memory bandwidth. Can you kind of explain that again and why it's such a big deal for these memory layers?
Think of it this way. You have this incredible library filled with knowledge, but the doorways are really narrow.
Right.
So only a few people can go in and out at a time.
So even if the library is huge, that flow of information in and out is restricted. Okay, so memory bandwidth is essentially the speed limit for how fast the AI can access information in those memory layers.
Exactly. And as we scale up these memory banks to hold more and more information, that bandwidth becomes even more critical.
It's like building a bigger and bigger library, but if you don't also widen the doorways, you'll still have a bottleneck.
Right.
So what are researchers doing to address this bandwidth problem?
It's an active area of research. They're exploring new hardware architectures, more efficient algorithms, and even, novel ways of organizing data within the memory layers to kind of optimize those access speeds.
It sounds like a pretty complex engineering challenge. Are there any other limitations that researchers are kind of grappling with when it comes to memory layers?
Another challenge lies in striking the right balance between memory capacity and computational cost. So as we scale these memory banks to hold, ever-increasing amounts of information, the computational resources required to manage and process that data can also skyrocket.
So it's like building a bigger and bigger library, but you also need a more and more powerful generator to keep the lights on.
That's a good way to put it. It's a delicate balancing act. Researchers need to find ways to maximize that memory capacity without overwhelming the computational resources that are available.
It makes you wonder, are there any fundamental limits to how big we can actually make these memory layers? Is there a point where we kind of hit a wall, either in terms of memory capacity or computational feasibility?
That's a question that's still being explored. It's possible that with current hardware and algorithms, we might eventually reach a ceiling, but remember, technology is constantly evolving.
So it's not necessarily a dead end, just a challenge that might require, new breakthroughs in hardware or software to overcome.
Exactly, and that's what makes this field so exciting. There's always a new frontier to explore, a new puzzle to solve.
It's like the Wild West of AI, with pioneers pushing the boundaries of what's possible. Speaking of pioneers, what are some of the other exciting developments happening in the world of memory-augmented AI? What other directions are researchers exploring?
One particularly intriguing area is the integration of memory layers with other cutting-edge AI techniques. Remember those mixture of experts models we discussed earlier?
The ones where different parts of the AI specialize in different tasks? Yeah, those were fascinating.
Imagine combining the factual prowess of memory layers with those specialized skills of different experts. It's like assembling an AI dream team, each member with their own unique strengths.
So we could have one expert specializing in language translation, another one in image recognition, and yet another in creative writing, all backed by this massive shared memory bank filled with facts and knowledge.
That's the idea. By combining different AI approaches, we could potentially create systems that are not just more knowledgeable, but also more versatile and adaptable.
It's like building a Swiss Army knife of AI, with all the tools you need for any situation.
Exactly. And this kind of modular collaborative approach to AI development could have profound implications for how we solve real-world problems.
Like what? Can you give me some concrete examples of how this memory-augmented multi-expert AI could change our lives?
Imagine personalized healthcare systems that can instantly access your entire medical history, analyze genetic data, and suggest the most effective treatment options tailored specifically to you.
Wow, that would be a game changer for medicine. What else?
Or think about smart cities that can optimize traffic flow, manage energy consumption, and even predict and prevent crime, all in real time using a combination of data analysis, machine learning, and of course, memory-augmented AI.
It's like having a super intelligent operating system for an entire city. It's both exciting and a little daunting to think about the potential impact of this technology.
I agree, but one thing is certain. Memory layers are playing a pivotal role in shaping the future of AI, paving the way for systems that are not just bigger and faster, but also smarter, more adaptable, and ultimately more beneficial to humanity.
Before we move on, I want to circle back to something you mentioned earlier, the idea that memory layers could change how AI learns. We talked about how these layers can reduce interference between different pieces of information, leading to more robust and durable learning. Can you unpack that a bit more? Why is this so important?
One of the biggest challenges in AI is something called catastrophic forgetting. It's this tendency for AI models to forget old information as they learn new things. Imagine you're learning a new language, but as you start to master the new grammar and vocabulary, you start forgetting your native language.
Oh, it'd be a disaster. So catastrophic forgetting is basically when the AI overwrites old knowledge with new knowledge, like saving over an important file on your computer.
Precisely. And this can be a major roadblock for developing AI systems that can truly learn and adapt over time.
So how do memory layers help with this?
The way memory layers learn through these sparse updates seems to mitigate this problem, because only a small portion of the memory is modified at a time. It's less likely to disrupt that previously learned information. Think of it like having different compartments in a suitcase.
So instead of just throwing everything in and hoping for the best, we're organizing the information carefully so that new knowledge doesn't overwrite old knowledge.
That's a great way to put it. And This ability to compartmentalize knowledge could be essential for developing AI systems that can learn continuously and cumulatively without forgetting the lessons they've already learned.
This is incredible. It sounds like memory layers aren't just about improving factual accuracy. They're fundamentally changing how AI learns and interacts with the world.
I believe so, and that's what makes this research so groundbreaking. It's not just about building bigger brains, it's about understanding how those brains learn and adapt.
This has been a mind-blowing journey so far. We've explored the inner workings of memory layers, their potential to really revolutionize AI, and the challenges researchers are tackling to unlock their full potential.
And in the final part of our deep dive, we'll shift gears and explore the broader implications of this technology, the potential impact of memory layers on society, the economy, and the future of work.
Join us next time as we delve into the uncharted waters of AI's future and grapple with the profound questions that memory layers raise about the nature of intelligence itself. Welcome back to our deep dive. We've been on this incredible journey exploring these memory layers. It's kind of amazing to think that AI could have these, dedicated knowledge banks, almost like a separate part of their brain just for facts.
It is remarkable, and it's not just about storage. These memory layers seem to fundamentally change how AI learns, making it more efficient and potentially even more human-like in its ability to acquire and retain knowledge.
But with any powerful technology like this, there are always those big what-if questions. What happens when this becomes commonplace? How does this reshape, the world as we know it?
Yeah, those are the questions we need to be asking. One of the biggest shifts might be in the nature of work itself. Imagine a world where AI can handle any task that relies on accessing and processing information.
Right. So much of what we do now, research, data analysis, even things like customer service could potentially be automated. It's both exciting and a little bit, unnerving at the same time.
It is, and it raises some serious questions about, the future of the workforce. How do we adapt our education systems and training programs to prepare people for a world where these skills might be less in demand?
Right. It's almost like we need to start thinking about how to complement AI rather than compete with it.
Yeah.
What other aspects of society do you think memory layers will impact, most significantly?
I think the way we learn and access information will change dramatically. Imagine a world where AI tutors can personalize learning experiences for each student, instantly adapting to their strengths and weaknesses.
It would be like having a world-class expert at your fingertips, guiding you through any subject you want to learn. That could really democratize education and make lifelong learning more accessible, to everyone.
Exactly. And it goes beyond formal education. Imagine having AI assistants that can provide us with accurate, up-to-date information on any topic, instantly.
No more sifting through unreliable websites or, outdated textbooks. You could literally ask your AI assistant anything, and it would draw on this vast knowledge base to give you a reliable answer.
Precisely. And this could have a profound impact on how we make decisions, both individually and as a society. Imagine policymakers having access to AI systems that can analyze complex data and, model the potential outcomes of different policy options.
It could lead to, more informed evidence-based decision-making. But it also raises questions about trust and transparency, right? How do we ensure that these AI systems are actually providing unbiased, objective information?
That's a crucial point. As we delegate more and more of these cognitive tasks to AI, we need to develop, clear ethical frameworks and governance mechanisms to ensure that these systems are used responsibly and transparently.
So it's not just about the technical advancements. It's about the societal and the ethical implications that come along with them. We need to have these conversations now while the technology is still evolving to shape its development in a way that benefits humanity.
I completely agree. We're at a pivotal moment in history where we're on the cusp of creating AI systems that can potentially surpass human capabilities in many domains. It's both exciting and, a little bit frightening.
It is, but I think the key takeaway from our deep dive here is that memory layers are not just a technical innovation. They represent a fundamental shift in how we think about AI and its role in our world.
Exactly. It's a reminder that as we push the boundaries of what AI can do, we also need to expand our thinking about what it means to be human in an age of intelligent machines.
It's the conversation that we all need to be a part of. And as we wrap up this deep dive on memory layers, I encourage you to keep exploring, keep questioning, keep imagining the possibilities. The future of AI is being written right now. It's up to all of us to shape it responsibly.